Right, so our set from before was the exact same as after. We kept the check for understanding. It fit nice. It had a nice flow, we thought. And we gave them this question, which was just a negative exponent question, to give them a chance. You know, if one student could figure it out, give them that chance. But most students probably wouldn't get that, and that'd be a great way to lead into try to find a chart and go through how to find this problem.
Okay, so original development was to look at some of these exponents here and use mainly inductive reasoning to get the answer. And then we wanted to realize that multiplying by 2 the number of times is how you get the exponent. So if it's 2 to the 4th, you have to multiply by 2 4 times. And then we had a lot more inductive reasoning. Most of this was with inductive, and then we only had one little thing of deductive reasoning at the end here. So we wanted to get into that a little bit more. So this is what we had before.
Okay, our development after, like I said, we incorporated a proof as to why, for example, 2 to the 0 would equal 1. We also introduced a fraction, given a fraction and a negative exponent, and we also introduced the term reciprocal, or if students wanted to call it, the flip. So, yeah.
Right, so our closure from before, it was, I don't know, it needed some work because all it was giving them a worksheet, that the worksheet wasn't actually very good either. But it was intended for them just to get the practice, and we wanted to introduce the expanded exponential notation in some way. You'll see a little bit later once we get to that point. But so our closure after was just going through what we did in class, bringing out the flip, the reciprocal, and just pretty much looking at what we did. Then tomorrow we will be looking at the expanded exponential notation.
The extension activity before, it says here, if the lesson is progressing quickly, continue with expanded exponential notation, but if need be, the intro into expanded exponential notation can be left for the next day. So we wanted to leave this as an extension activity of the type where we would cover it if we had time. If we didn't, we would just bring it up the next day. And what we changed this to was introduce it, spend a little bit of time on it because we wanted to get some more doctor in there, and then ask what a couple numbers are in expanded exponential notation. So we didn't want to spend a lot of time on it, but we wanted to introduce it so that they'd have a little bit of lead-in for the next class.
Alrighty, so again, this is the proof. We just included the proof that we used. I guess this is part of our extension as well. This was the assignment before. Again, a lot of the examples were really general, didn't really expand on what we learned today. Here we also have some other reflection type questions. We're asking students to make their own chart and, why do you use exponents? What we added, again, we introduced fractions and negative exponents. So we included a couple of examples of those. We had examples where we asked students to determine which value, I guess, would be greater or less than. But instead we added number lines so that they could actually draw them out and see visually where they lie on a number line. Again, we kind of changed the reflection question. So number 3 says, summarize your findings when an integer has an exponent of 0. So again, more of looking at what they've just learned. And then the last part here, why do we use exponents? We kind of included hint, if you are having trouble, try evaluating this into your calculator, just so again, students can see the difference. Maybe it helps them to get an idea of why they're important and why we use them in math. So